The 30 amp limitation for overcurrent protection on number 10 copper wire, as stated in National Electrical Code section 240.3, applies regardless of the insulation temperature rating, meaning it applies to both 90 degrees Celsius insulation as well as 75 degrees Celsius insulation. While Table 310.16 might indicate a higher ampacity like 35 amps for a number 10 copper conductor with 90 degrees Celsius insulation, that ampacity cannot be used with a 35 amp breaker because the overcurrent protection limitation specified in National Electrical Code section 240.3 takes precedence and overrides the ampacity specified in Table 310.16. This limitation is in place because the overcurrent protective device, often a circuit breaker or fuse, is designed to protect the conductor itself from overheating in the event of a short circuit or an overload condition. The 30 amp limitation ensures that the number 10 conductor will not exceed its safe operating temperature even under fault conditions. The National Electrical Code provides minimum safety standards for electrical installations. These standards are intended to protect people and property from electrical hazards. One of the key aspects of electrical safety is proper overcurrent protection. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from excessive current, which can cause overheating, fire, and other hazards. The ampacity of a conductor is the maximum current that it can carry continuously under specific conditions of use without exceeding its temperature rating. The ampacity of a conductor is determined by several factors, including the size of the conductor, the type of insulation, the ambient temperature, and the number of conductors in a raceway or cable. The National Electrical Code provides tables that list the ampacities of various types of conductors under different conditions. Table 310.16 is one such table, and it provides ampacities for conductors insulated with various materials, such as thermoplastic high heat-resistant nylon, thermoset, and cross-linked polyethylene. The notes to Table 310.16 provide adjustments to the ampacity for ambient temperature and the number of conductors in a raceway or cable. National Electrical Code section 240.3 provides the rules for overcurrent protection of conductors. This section requires that conductors be protected against overcurrent in accordance with their ampacities. However, National Electrical Code section 240.3 provides an exception to this rule for certain small conductors. This section states that the overcurrent protection for number 14 copper conductor shall not exceed 15 amps, for number 12 copper conductor shall not exceed 20 amps, and for number 10 copper conductor shall not exceed 30 amps. This limitation applies regardless of the ampacity of the conductor as determined by Table 310.16. The purpose of this limitation is to protect the conductors from overheating in the event of a short circuit or overload. Number 14, number 12, and number 10 copper conductors are commonly used in residential and commercial wiring. These conductors are often used to supply power to lighting fixtures, receptacles, and other small appliances. The National Electrical Code recognizes that these conductors are often subjected to overload conditions, such as when a receptacle is overloaded with too many appliances. To protect these conductors from overheating, the National Electrical Code limits the size of the overcurrent protection device that can be used. The 30 amp limitation for number 10 copper conductors is based on the conductor's ability to dissipate heat. When a conductor carries current, it generates heat. The amount of heat generated depends on the amount of current flowing through the conductor and the resistance of the conductor. If the conductor is not able to dissipate heat quickly enough, it will overheat. Overheating can damage the insulation of the conductor, which can lead to a short circuit or fire. The 30 amp limitation for number 10 copper conductors ensures that the conductor will not overheat under normal conditions of use. The limitation applies regardless of the type of insulation used on the conductor. This is because the insulation is not the primary factor in determining the conductor's ability to dissipate heat. The primary factor is the size of the conductor. A larger conductor has a greater surface area, which allows it to dissipate heat more quickly. Therefore, when using number 10 copper with 90 degrees Celsius insulation, the maximum size of an overcurrent protection device that can be used is 30 amps. Even though Table 310.16 may allow a higher ampacity, the overcurrent protection device must be sized in accordance with National Electrical Code Section 240.3. In summary, firstly, National Electrical Code Section 240.3 limits the overcurrent protection for number 10 copper conductors to 30 amps, regardless of the insulation type. Secondly, Table 310.16 may show a higher ampacity for number 10 copper conductors with 90 degrees Celsius insulation, but this ampacity cannot be used with a breaker larger than 30 amps because National Electrical Code Section 240.3 takes precedence. Thirdly, this limitation is in place to protect the conductors from overheating in the event of a short circuit or overload. And fourthly, when using number 10 copper with 90 degrees Celsius insulation, the maximum size of an overcurrent protection device that can be used is 30 amps. It's crucial to understand that the National Electrical Code provides minimum safety standards. Adhering to these standards ensures electrical systems are safe and reliable. The overcurrent protection requirements are a critical part of these standards. Always consult the latest edition of the National Electrical Code and seek guidance from a qualified electrician when designing or installing electrical systems. Correctly applying the code ensures the safety of people and property. The ampacity of a conductor is also affected by the ambient temperature. The ampacity of a conductor is reduced as the ambient temperature increases. This is because the conductor is less able to dissipate heat in a hot environment. The National Electrical Code provides tables that list the ampacity correction factors for different ambient temperatures. These correction factors are used to adjust the ampacity of a conductor for ambient temperatures above 30 degrees Celsius or 86 degrees Fahrenheit. The number of conductors in a raceway or cable also affects the ampacity of a conductor. The ampacity of a conductor is reduced as the number of conductors in a raceway or cable increases. This is because the conductors are less able to dissipate heat when they are close together. The National Electrical Code provides tables that list the ampacity adjustment factors for different numbers of conductors in a raceway or cable. These adjustment factors are used to adjust the ampacity of a conductor for the number of conductors in a raceway or cable. In addition to the factors mentioned above, the ampacity of a conductor can also be affected by other factors, such as the type of load that the conductor is supplying, the length of the conductor, and the altitude at which the conductor is installed. The National Electrical Code provides guidance on how to account for these factors when determining the ampacity of a conductor. When selecting a conductor for an electrical circuit, it is important to choose a conductor that has an ampacity that is sufficient for the load that the circuit will be supplying. It is also important to consider the ambient temperature, the number of conductors in a raceway or cable, and any other factors that may affect the ampacity of the conductor. By carefully considering these factors, you can ensure that the conductor will be able to safely carry the current that it is required to carry. Understanding the relationship between National Electrical Code Section 240.3 and Table 310.16 is crucial for safe and compliant electrical installations. Always prioritize the most restrictive requirement to ensure the protection of conductors in electrical systems. Consider a scenario where you are wiring a lighting circuit in a residential building. The circuit will supply several LED resist lights, and the total calculated load is 20 amps. You are using number 10 copper wire with 90 degrees Celsius insulation. According to Table 310.16, the ampacity of number 10 copper wire with 90 degrees Celsius insulation is 35 amps. However, National Electrical Code Section 240.3 limits the overcurrent protection for number 10 copper wire to 30 amps. Therefore, you must use a 30 amp circuit breaker to protect the circuit. Even though the wire is capable of carrying 35 amps, you are limited to 30 amps by the National Electrical Code. This ensures that the wire will not overheat in the event of a short circuit or overload. Another important consideration is the terminal temperature rating of the equipment to which the conductor will be connected. The terminal temperature rating is the maximum temperature that the terminals of the equipment are designed to withstand. The National Electrical Code requires that the conductor be sized so that its ampacity is not greater than the terminal temperature rating of the equipment. For example, if the terminals of the lighting fixtures are rated for 75 degrees Celsius, you must use the 75 degrees Celsius ampacity of the conductor. In this case, the 75 degrees Celsius ampacity of number 10 copper wire is 30 amps. Therefore, you would still be limited to a 30 amp circuit breaker. The National Electrical Code is a complex document, and it is important to consult with a qualified electrician to ensure that your electrical installations are safe and compliant. An electrician can help you determine the correct conductor size and overcurrent protection for your specific application. Failing to comply with the National Electrical Code can result in serious consequences, including fire, electrical shock, and property damage. Therefore, it is essential to take the time to understand the code and follow its requirements. The National Electrical Code is updated every 3 years, so it is important to stay up to date on the latest changes. You can purchase a copy of the National Electrical Code from the National Fire Protection Association or from your local bookstore. You can also find information about the National Electrical Code online. The National Electrical Code is an important tool for ensuring electrical safety. By following the requirements of the code, you can protect yourself, your family, and your property from electrical hazards. Remember that electrical work can be dangerous, and it is important to take precautions to protect yourself from electrical shock. Always turn off the power to a circuit before working on it, and use insulated tools. If you are not comfortable working with electricity, hire a qualified electrician to do the work for you. The number 10 wire, limited to 30 amps overcurrent protection per National Electrical Code section 240.3, often gets used for things like air conditioning condensers, electric water heaters, or even electric stoves and ovens depending on the load calculation and overall design. Because the table allows a higher ampacity based on its insulation, it is critical to remember that the code section 240.3 always overrides the higher ampacity, if there is one, found in the table. This ensures safety by preventing the wire from overheating under fault conditions. The standard applies regardless of where the wire is installed, whether it is in Illinois or anywhere else where the National Electrical Code is adopted. It is important to always refer to the latest version of the National Electrical Code to ensure compliance with the most current regulations and safety standards. Also be aware of any local amendments or requirements that might further restrict or clarify these guidelines. Always consult with qualified electrical professionals for specific applications and interpretations of the code. Understanding and adhering to the National Electrical Code is essential for preventing electrical hazards and ensuring the safety of electrical installations. While specific situations may require more in-depth analysis, following the core principles outlined in the code provides a solid foundation for safe and compliant electrical work. Always prioritize safety and seek expert advice when needed. The National Electrical Code is designed to protect both people and property, and its guidelines are essential for maintaining safe electrical systems. So, to reiterate, the 30 amp overcurrent protection rule for number 10 copper wire in National Electrical Code section 240.3 applies irrespective of the insulation temperature rating, and it overrides the higher ampacity values found in table 310.16. This is a critical safety measure to prevent overheating and ensure the longevity and reliability of electrical wiring. The National Electrical Code guidelines are not just suggestions, they are essential standards that help to minimize the risk of electrical fires, equipment failure, and potential harm to individuals. Therefore, any individual that is working with electrical systems needs to not only understand the NEC but apply it as intended to ensure a safe environment.